We'd like to thank the folks from CL Aftermarket Products for sponsoring our webinar series. Without those guys, it'd be very difficult for obviously us to be able to bring this to all the shops literally across the world. So again, thanks to those guys, and we certainly appreciate their help and support. If you're having a question about ATRA, please feel free to get a hold of Lance at lwiggins@atra.com. You should be able to answer any type of questions you have about membership or technical issues or any other little issue that you may have that you want to discuss with somebody at ATRA here in the United States. On the connection side of it, make sure you're a hardwired connection. Again, we've talked about that in the past rather than a wireless type connection. Your handout itself is a PDF format handout. Everybody should have received the handout. If you didn't, you can get a hold of Reese there in Australia, or also you can get a hold of Lance at ATRA, and you should be able to get your copy of the handout. If you got a question as we're going through this today, feel free to ask your question. We certainly appreciate you having questions. The simplest and easiest way to do that is to simply type your question in, hit the submit key, and that question will then pop up on my screen. You can also raise your hand if you'd like, and I'll obviously call on you, and you can ask your question via your microphone if you'd like. Last but not least, the survey we have is an automated survey that follows the presentation. Again, appreciate everybody filling that survey out because it kind of gives us an idea of where we're going with everything, and so that we obviously know what types of webinars you guys would like to have. The next webinar we're going to have is on Chrysler rear-wheel drive transmission diagnosis, and for you guys it's going to be on the same day, December, I guess it's going to be December 3rd for you guys. Actually be December 4th for you guys at the same time in the morning. So again, we certainly appreciate you guys attending our webinars, and we again look forward to servicing you here in the future. Now let's start talking a little bit about the transmission that we're dealing with here today, which is the 4L60E. We're going to start off dealing with how this transmission actually makes the shift transitions for the 4L60E transmission. As you can see, we've got some shift valves and so forth up on the screen. When you're in first gear with this box, you're going to start out obviously with both shift solenoids in the on position. That's going to basically block the exhaust from both solenoids. So as you can see, the shift valves would be in their downshifted position. When I want to make a shift to second gear, it's really pretty simple. All I do is turn off the 1-2 shift solenoid, which is shift solenoid A. So as that solenoid goes into the off position, we exhaust the 1-2 signal oil on the end of that solenoid assembly, which then of course allows the spring tension on the opposite end where my red arrow is at to shove that shift valve over in the upper position. That makes our upshift. So as that oil rolls through that 1-2 shift valve, D4 oil becomes second gear oil pressure. As you can see, as it comes out the bottom of that shift valve, it goes to a junction. That junction feeds your 2-3 shift valve. That 2-3 shift valve is fed so that you can make your shift to third gear. So if the 1-2 shift valve in a 4L60E is to stick in the downshift position, not only do you not have second gear, you also do not have third gear with this box. So again, that's kind of important. You realize that throughout this transmission, both the 1-2 and the 2-3 shift valve train are what they call series-fed shift valve trains. So it won't just cost you one gear, it will cost you more than one gear if a valve actually hangs up. As we come through that 1-2 shift valve, as you can see, we're making a left-hand turn there on your picture, coming over to the middle of the page and down, and then another left-hand turn that comes over to the side of the page itself. As you can see that red arrow there showing you check ball number 8. Check ball number 8 is probably one of the more important check balls when it comes to shift feel for us. This ball has given us lots and lots of problems. So again, the problems we run into typically is the ball blows through the seat of the spacer plate or fails to seat on the spacer plate, allowing you to have extra oil volume fed to the servo, causing a hard 1-2 shift. So again, that ball becomes really critical that it is operating and operating correctly. As you can see, parallel to that ball, you got the little valve that's called the 3-2 downshift valve. That 3-2 downshift valve is controlled by the 3-2 downshift solenoid, and the job of that is if we're doing a forced downshift, like a hard throttle downshift, that regulates the apply rate of that solenoid on the downshift itself. So we regulate the apply rate, obviously, of the 2-4 servo as the servo tries to come back on. Now, if that 3-2 downshift valve, since it's parallel to the number 8 check ball, is to stick in the open position, you're going to end up having or bypassing the number 8 check ball, giving you a very aggressive apply, obviously, of the 2-4 servo. So if you run across an issue with a hard 1-2 shift, this would be another thing that we'd want you to check, would be the operation of the 3-2 downshift valve. As that oil pressure comes out of the number 8 check ball, down the page itself and into my accumulator, as you can see, we branch there at the bottom of the accumulator. The oil feeds over to the servo, and of course it feeds up into the 1-2 accumulator. Now, that 1-2 accumulator may have one spring in it, and may have 2 springs in it. The springs could be on either side of the piston, all depending on the model code of the transmission itself. So it's imperative that unless you keep track of the springs, where they went, that you get the book out and physically look at those spring combinations so that you know you're putting the right springs in that particular transmission. So again, real important that you get that squared away in your mind before you put the transmission together. The other thing I should note to you guys, it's really important to you because you got so many the Holdens over there that have the 4L60Es in them. Starting in the 2002 model year, that whole accumulator housing was changed. They updated it and increased the stroke of that piston by 25%. What's that mean to me in simple terms? That means that that accumulator housing out of 2002 and later is not interchangeable with the 2001 and earlier accumulator housing, or else you're going to end up with shift problems on the 1-2 shift. So again, can't overemphasize that. That whole housing, the springs, as well as the piston were physically changed because of the need to stabilize that 1-2 shift a little bit more and give them a little bit more ability to cal in pressure control values to get the shift right. So that's the whole idea behind having that accumulator assembly the way that it is. Now, as we travel over into the 2-4 servo, as you can see, we got a piston on the inside of the 2-4 servo that's going to stroke that servo pin on. Again, this is an area that could cause you a major problem with a 1-2 shift based on the fact that there are 4 different size second gear pistons and housings that fit in the 4L60E family of transmissions. Most guys are aware of 3 of them, but there's actually a 4th one that's out there that went in the 4L70E. So just be aware they are different diameter pistons for second gear apply, and the housing that fits over that is also a different diameter. So it becomes imperative that you have the right piston and housing if you want a good quality 1-2 shift. Now, the big spring that you see there in the picture that's going around that piston assembly itself, that large diameter spring is called a cushion spring. And again, some transmissions have different configurations of cushion springs. Some have 2 in there, some have 1 in there. Guys will sometimes leave those out, which is not a good idea. But again, bottom line is you want to make sure that you've got the right spring configuration in there. Last but not least, if you look at the servo piston itself, that's pushing on the servo pin. That pin is available in several different lengths. And again, especially if you're running a non-OE band, you're going to want to make certain that you double check that servo pin length to make sure it is correct. 2-3 shift. Now on the 2-3 shift itself, very simple. To make the 2-3 shift, all we simply do is turn off the 2-3 shift solenoid. So if you look at that solenoid, that's the second solenoid down there on the right-hand side. We're exhausting the signal oil. When we do that, that yellow oil pressure on the left-hand end of the 2-3 shift valve builds up, shoves that shift valve full right, which in turn then takes the oil pressure through that shift valve, as you can see coming down the page by my red arrow. That goes past the number 4 check ball and the number 2 check ball before it comes up into the number 7 check ball, which is that check ball capsule inside the servo bore itself, pressurizing the servo off. Now, it's real important you understand that they never release pressure on the servo once they start applying pressure. So my point is, if we're going up in gears, all we simply do is add pressure to a different surface area that forces the piston to move back and forth. Now, the other thing you can see, there is a red arrow there showing you oil pressure from this 3rd gear circuit also going up to the 3-4 shift valve. So that's my signal pressure for my 3-4 shift valve. So if we do not have a 2-3 shift, you will not have a 3-4 shift. So again, another series fed type shift valve train. Now, if I want to force a downshift from third gear into second gear, then what I'm going to do is one of two types of downshifts. Either the controller is going to control just the shift solenoid, or it's going to control the shift solenoid and the 3-2 control solenoid. So it depends on the severity of your downshift will determine whether it controls one downshift solenoid or one solenoid for the downshift, or actually both those solenoids for the downshift. That 3-2 solenoid has been redesigned in later years with the 4L60E. We started out with that solenoid one type of design and then went to the other style design. So we changed from a PWM solenoid to an on-off style solenoid. That was a change that was made back in the mid-90s time frame. So what that 3-2 solenoid does is that controls the rate of exhaust via that 3-2 downshift valve for that oil that's on the third gear side of the servo. So we can either let it go back through, obviously, the shift valve, which is regulating it based on orifice size, or we can dump it quicker through that 3-2 downshift valve. So again, we can control the aggressiveness of the 3-2 downshift very easily by doing that. Now, if you look at this particular picture, what you're seeing here is we're forcing the 2-3 solenoid back into the on position, which that blue oil pressure on the end of the 2-3 shift solenoid is building up, shoving that solenoid assembly, or I should say that valve assembly, full left in this picture, which then opens the exhaust, illustrated by the large red arrow right on the 2-3 shift valve train. So again, bottom line is we can regulate this thing a couple different ways, either by using the 3-2 solenoid and the 3-2 valve, or by simply allowing it to go back through the 2-3 solenoid and, of course, the 2-3 shift valve. When you look at the servo operation, you're going to see that it looks fairly complicated, but it actually is not. As you can see here, we've got second gear oil pressure being fed into the illustration on the left-hand side of the page, showing you the stroking on of that servo piston. That is the diameter we talked about is different between the four different servo pistons that are out there. There will be a number stamped on the inside diameter of that piston that tells you the part number for it. You can go to your parts person. They can tell you if that's supposed to fit your particular transmission code transmission or not, your model code. So again, 4 different sizes available, so you can vary your feel by varying the size of that piston. The other thing is, of course, your servo pin length. Again, if that servo pin is too short, you get a head start on the band. You're going to end up with a pretty aggressive apply when that servo comes on. Now, when we decide to go to third gear, we're looking at the middle illustration. All we're going to simply do is force the oil up through that number 7 check ball into the exhaust side of the servo piston itself, forcing the servo to move backwards as, of course, the transmission goes fully into third gear. We go to fourth gear, pretty simple operation in fourth gear. The pin, of course, is hollow, and of course have a piston that sets on the end of the servo piston, or servo pin itself. So when we pressurize that fourth gear circuit on the left-hand end of that picture that you see there, that orange pressure builds with that piston, and of course with the second piston, that exceeds the surface area you have in third gear, so of course the piston strokes back on again. 1-2 shift accumulation. Let's talk about it a little bit so everybody's aware of exactly how that works. The 1-2 accumulator, of course, this is the guy we talked about. The housings changed and the piston and springs have changed as of 2002. They have a different housing, piston, and spring configuration. You may find those springs, depending on what model you have, turned around. In other words, you may find 1 spring in the bore, you may find 2 springs. Different color code springs mean that there are different spring tensions. You may find the piston down and the springs up, or the springs down and the piston up. All depends on your particular application. So you're going to have to look at your shop manual for your particular application and make sure that the configuration is correct for your application that you're working on. Now, if you look at the picture of the hydraulics, as you can see, there's an accumulator control valve that's controlled by torque signal oil, so your line pressure control, and we simply vary that green pressure based on what our line pressure is doing. So engine torque that we've got going into the engine is going to vary my line pressure, which is going to vary this green pressure, which is actually the feedback pressure on the back of the accumulator piston itself. So as that green oil pressure goes in there, the more oil pressure in on top of that 1-2 accumulator piston or 3-4 accumulator piston, that's going to simply mean the harder it is for the piston to move, which makes the band more aggressive on its apply. Now, that accumulator valve, obviously, if it's to hang up, and it hangs up with it open in the open position, so that means we've got more oil pressure in there. It's going to give you a very aggressive shift. There are several different spring configurations for that accumulator valve, so you're going to want to make certain that that accumulator valve spring tension is correct in your application, or you can end up with a very either a sloppy type 1-2 shift or a very aggressive type 1-2 shift. So that's the gist of how that whole thing works. Now, we talked about operation of this transmission itself as far as the shift operations are concerned. Let's go through and look at some of the things that can cause a hard 1-2 shift. We talked about the number 8 check bulb. We said it's common for that check bulb to actually beat itself through the spacer plate. If that happens, you're going to end up with a very aggressive 1-2 shift. Again, real common. In fact, there are hardened plates that are out there in the industry to address this as an issue. Any DTC that sets that can raise line pressure will cause the customer to complain about the 1-2 shift. He won't complain about other shifts because they are using clutches typically, but when you're dealing with a band, you have to really watch what your pressures are because a band is much more aggressive on the apply than a clutch is. So when you elevate line pressure for any reason whatsoever, you end up with a situation where you have an aggressive shift. In this instance, it happens to be on the 1-2. So if you have a DTC set, well, you need to fix that DTC prior to working on the transmission. Number 3, we're showing broken, stuck, damaged, incorrectly installed accumulator pistons and springs. We talked about the fact that there are different spring color codes. Some have 2 springs, some have 1 spring. Some, the spring goes on one side of the piston, some the spring goes on the other side of the piston. So you got to look to make sure you have your spring configuration correct for your particular application. Sticky, damaged, or incorrectly installed accumulator valves or springs, pretty simple there. So if that valve was to hang up, as we talked about earlier, you end up with too much back pressure behind the accumulator piston, which makes your shift very aggressive. Now, I've never ever seen this one here, but I've heard it from several guys, so we're putting it on the screen here. Accumulator valve bushing installed backwards. It is possible to actually turn that whole assembly around. I'm not sure exactly why guys are doing that. I guess just not paying attention to it real closely. But the bottom line is you push it, turn it around, and you shove it in far enough to get your retaining pin in. Then what ends up happening is you'll end up with a situation where the passages are partially blocked off or fully blocked off for that accumulator, which basically then means you have no accumulation, no shift accumulation. 4-3 sequence, 3-4 relay, 3-2 downshift valve. We've talked about those before. So nothing razzle-dazzle about that. The 3-2 downshift valve is very common for causing this hard 1-2 shift. If that valve is to hang in the open position, effectively what happens is that valve is bypassing the number 8 check ball. So it's kind of like not even having the ball there. Number 6, probably the most important of all of these, because you're going to notice that there's going to be a lot of calibrations out there for 1-2 shifts that are aggressive. So make sure you go to the website, the GM website, check your calibration number with your scan tool, correspond it to the website, make certain that you have the correct calibration in your application. Now, this doesn't apply a lot to you guys that are in Australia because you don't have a lot of the trucks that are out there. You may want to run across one once in a while. We had some troubles on the pickup trucks with EMI from the alternator itself on the 2002, 2003 applications. In fact, we came out with a kit to isolate the EMI as an issue. So again, if you're dealing with an imported vehicle like a Chevy truck or a GMC truck and you're having troubles with the 2002, 2003, disconnect your alternator, see if the hard shift problem goes away. If it does, you're going to have to install the kit. Mass airflow map sensor problems, starting back, clear back in 1997, including on the Holden applications, we went to basically torque modeling for all of the line pressure controls, which basically then means that you have to use map and MAF as your inputs to determine what your line pressure should be. So a problem with either the map sensor or the MAF sensor are going to cause you a problem with line pressure, which is going to be interpreted by the customer as an aggressive 1-2 shift, because the line pressure rise affects the 1-2 shift way worse than any other shift. Band material composition or drum finish, real important to us. On band material and composition, just be aware that there are some aftermarket bands out there that do not have the same dynamic coefficients of friction that obviously the factory bands do, and it can cause you some shift, obviously, issues with that. So just be aware of that as you're going through rebuilding these transmissions. Faulty pressure control solenoid, stuck AFL valve, they kind of go hand in hand with each other. As we just talked about earlier, if we have a problem with the pressure control solenoid, you're going to end up with the customer interpreting that as a hard 1-2 shift. Same with the AFL valve. So the actuator feed limit valve, we're used to it leaking pressure, which means you have low line pressure boost, but that valve can also stick. And if it sticks in the high pressure position, you're going to end up in a situation where you have more pressure going into the solenoid than you're supposed to, which then means obviously that you're going to have obviously a very aggressive shift from first to second. Wiring issues, any kind of wiring issue can affect the operation of the pressure control solenoid, will certainly affect your 1-2 shift. And finally, last but not least, servo pin length. So if the servo pin length is incorrect, usually the pin is too short, you're going to end up with a pretty aggressive apply because effectively the servo has a running start at the band as it hits the band. So now let's take a look at each of those individually so you have an idea of exactly what's going on with each one individually. So here's the number 8 check ball, the seating area of the number 8 check ball itself. So as you look at this thing right here, we're saying the ball should seat on that large hole there. The orifice is a little small hole. Again, if it's blown through the plate, you may want to consider getting an aftermarket hardened plate for your application. Any DTCs that are set, you need to address those first. So as we look at this DTC here, caused by obviously a torque converter clutch code being set, because we've got a leakage issue inside, obviously on the bushing and seals, you need to take a real hard look at anything that will cause a trouble code. Because any codes that are set, if the default action of that code is high line pressure, the customer is not going to complain about that. He's going to complain about an aggressive shift. Here's my 1-2 accumulator piston and spring we talked about. And again, remember in the 2002 model year, this was updated. Real important you understand that. There was a 25% increase in stroke on that piston at that point. And you'll end up in a situation if somebody's trying to intermix these with massive 1-2 shift concerns. So make sure you got the right springs in, make sure they're configured on the correct side of the piston, and of course make sure you got the right housing and piston assembly, because again, that was an update for anything 2002 and later, and non-interchangeable with the early model ones unless you want some shift concerns. Here's my accumulator valve, as you're going to see popping up right here. So we're looking at the accumulator valve and sleeve and spring. That spring has had several changes, so you're going to want to check your bulletins on spring update part numbers. The valve hanging up has been an issue with us quite a bit, so guys pull it out to clean everything. And again, like we talked about, make sure that you get that sleeve back in the correct direction. Again, I guess it is possible to get it in. I've never seen it myself, but guys have told me about other people have done it. And when that happens, of course, you're going to end up with passages being blocked and aggressive 1-2 shifts. The two valves we want you to look at, valve trains that we want you to look at, 3-4 relay and 3-2 downshift valves. Those are the two valves you got to check real closely because either of those can cause you aggressiveness as far as the operation of the band is concerned. Now there were several calibration updates that were made to this transmission starting in the 2006 model year. So you're going to want to check your Cal ID information, make sure your calibrations are updated. What they did with this calibration update was they increased the shift adapt learning authority. And what's that basically mean to us? Well, effectively what that means is that they allow the adapt tables to learn more. So they actually give you more adjustment than what you had before. So again, if you're looking at a problem with a hard 1-2 shift, several CALs are out there, and primarily what this CAL does is increases your abilities of your adaptive learning to take care of any build issues that you may have. I'm giving you a list of some spring codes here, both the 2-spring and the single spring models. This is just a couple of years. This is nowhere near an inclusive list, guys. So you're going to want to look at your shop manual. This is an example of this so that you don't overlook, obviously, whether you're supposed to have 1 spring in it, 2 springs in it, and how your configuration is supposed to be laid out. We talked about the Shudder issue. Again, this is a 2002-2003 issue. And again, primarily on trucks, so you guys won't see it there much in Australia and New Zealand. But if you do run into one, disconnect your alternator. If the problem goes away, then simply install the kit. And the kit is simply an AC Delco kit. Problems with mass airflow sensor or MAP sensor, as I talked about before, both the MAP and MAP are now used for torque modeling. So they're your primary line pressure control. So if you have a problem with the MAP or MAP input, you're going to skew your line pressure values, which in turn means the customer won't complain about that. He's going to complain about the fact that the 1-2 shift is aggressive. We talked about this quite kind of in detail. If you're using an aftermarket band or drum, you're going to want to make sure that the surface area and the coefficient of friction values are where they're supposed to be. Again, if you're running into troubles, you may want to switch suppliers to make sure that you're getting what you need to be able to get for your particular application, because either surface finish on the drum or dynamic coefficient of friction on the band will certainly impact the operation of that transmission during a 1-2 shift. Faulty pressure control solenoids, we talked about those a little bit earlier. We said there are two different types of solenoids out. Got the Borg-Warner, as you can see on the left-hand side, and of course the Delphi here on the right-hand side. If you have a failure of the solenoid, of course it can stick in the high pressure position, which will then lead you to problems with the 1-2 gear interchange. The valve that actually feeds that solenoid is a valve called an actuator feed limit valve. And of course it can be worn out, which means it's going to leak like a sieve, which means you're not going to have line pressure boost like you're supposed to have, which then leads you to transmission problems as far as burned clutches and so forth. But you can also have that valve stick. And if that valve sticks into the high pressure position, you're going to end up with more pressure going to the solenoid than you're supposed to. And the solenoid, of course, doesn't know that. There's no line pressure transducer on a 4L60E to tell us what the line pressure is actually doing. So it's basing its calculations off of having the actuator feed limit valve work and work correctly. So if that valve is to hang up, you're certainly going to end up with 1-2 shift problems. Problems with electrical wiring. This happens to be a picture of the UBEC right here, the Universal Bus Electrical Center itself. This is the guy that's mounted underneath the dash, your big giant fuse box, or I should say mounted in the fender well of the vehicle, big giant fuse box. This is not the only place that we have some electrical problems. We've also had some connection issues at the transmission pass-through connector. We've had some issues, obviously, on the wiring as it comes across the valve body on these 4L60Es. So any type of electrical issue that you actually have, wiring-wise, can cause you to have elevated line pressure, which then relates again to having a hard 1-2 shift. Here's my servo pin and servo piston we talked about. That number 17 and number 20 is what's different from model to model. So those are going to vary. And there's, again, contrary to common knowledge, there's actually 4 of those different pistons and housings out there. Most people are aware of 3 of them, but there's actually a 4th one. The 4th one came out with a 4L70E. And so bottom line is you're going to want to make sure that dimension is correct, or else you can have a shift issue. In fact, a lot of guys will actually vary those piston and housing sizes to control the clamp load on the band if they're getting into high torque situations and so forth. The second thing we want you to look at is at number 16 and number 105 springs right there. Those are your cushion springs. Again, make sure you got the right spring in there. Some of them use 2, some only use 1. You're going to want to make sure that there is a spring in there, because some guys will leave that spring out, and you'll get a very aggressive apply when they do that. Last but not least, we're going to check our pin length, make sure our pin length is correct, because again, if the pin is off, you can end up with a very aggressive apply of the band, because effectively the servo has a running start at the band itself. Well, that pretty well completes our webinar for today. It looks like we're right on time where we're supposed to be. So again, appreciate the guys from Steel Aftermarket Products supporting the webinars. Before we close here today, again, if you have any questions or anything you'd like to know about ATRA, you can contact L. Wiggins for Lance Wiggins at atra.com. And of course, if you have any questions that you need to ask me at this point, simply send me the question over and I'll try to answer it. When we're all done with this today, guys, there's going to be a survey that follows this. We'd appreciate your feedback on the survey. Simply fill the survey out. It's an automated survey. And again, we'd appreciate hearing back from you. If you got some ideas about webinars you'd like to have us do, or you are having some issues with the webinars and how they're coming through video or audio or whatever it happens to be, again, we'd like to hear that on the survey. So I don't see that we got any other questions that popped up. So again, guys, thanks very much for your time, and we appreciate you attending the webinars, and we'll see you on the next webinar.